Okay, our last transformation that we're going to look at is different from the first two, and that now we're going to be making a horizontal movement. We've been doing things vertically the last couple of classes. Today is going to be horizontal. And that difference is going to show up also in our formula. So when we look at our general transformation of any given function, I'll write it here on one line. Remember that f is our general function. F could be x squared, or f could be the square root of x, or f can be the absolute value of x, and so on. So what's inside the parentheses here, the x minus h, that means it's inside the function, which says that this other stuff is outside the function. So you have to think, if it's outside the function, it has a vertical effect. As a quick review, we know the vertical effect that a has is that it's going to stretch or make the function taller or skinnier. You can think of all those different ways. If a is bigger than 1, if a is less than 1, if you're multiplying by a number less than 1 but bigger than 0, so 1/2, 2/3, any fraction less than 1, it's going to do the opposite. It's going to have the opposite vertical effect. It's going to shrink the graph, make the y value shorter, make the graph wider. Vertical compression is the official mathematical term. And then also we have to consider what multiplying by a negative number does. If a is negative, it's going to reflect the function over the x-axis. So those are all the vertical effects that a have, and that's because we're multiplying our function, our y values, by a. Another way to think about this is this part right here is really just our y values. After you've plugged in x and you've done the function to the x, in other words, after you've plugged in x and you've squared it or square rooted it or cubed it or took the absolute value of it, you now have your y value. So that part in the brackets right here you can think of as our y value. So if I take my y and then multiply it by a, the y's are going to get taller or the y's are going to get shorter. That's why it has a vertical effect. Then if I take my y and I add k to it, if it's positive, if it's a positive number, if I'm adding 5, it's going to vertically translate up 5 units, or translate vertically 5 units, or translate up 5 units, however you want to say it. And if it's minus 3, then you're going to take all your y's and move them down 3, which would be, a vertical translation down. So if it's a negative number. So you have to remember that the outside stuff has a vertical effect. Things that are outside the function, not inside the parentheses here. Okay, so the stuff in the brackets is the y, but when I say inside the function, I mean inside the parentheses. Now here's the other thing about the horizontal shift. Because it's inside the function, it's going to do the opposite of what you would think. So I'll write it like this. Horizontal stuff horizontal effects are opposite of what they appear to be. In the function. You'll see what I mean when we go through this investigation. Now, just like the vertical effects, the horizontal effects, there's 2 of them. You could have a horizontal stretch or compression. Multiplying by a negative to the x value will reflect about the y-axis, but we're not going to actually investigate that in this course. We are going to just look at a horizontal translation. So that's what we're doing today, a horizontal shift. Do we just take it, and it's rigid, right? Because we're not stretching or compressing the function. So we're just taking that whole function and now going to slide it 5 units right or 3 units left. So we're just talking about a translation. That means slide right or left. All right, so what is the default value of h? So if I focus in on just the h, I'm not going to put in the a or the k. What would h have to be so that this would really just still be y equals f of x? That would be our default value. Well, if we're subtracting h from x, how do I end up with just x? If h is 0, that's our default value. If we subtract 0, nothing changes. We don't shift it, right? We would shift it left or right 0 units. So we're talking about adding and subtracting numbers here onto our x value. And since it's inside with the x-axis goes left and right or horizontally. That's why this thing's going to shift left or right horizontally. So let's do this investigation. Again, you're going to use something other than sine. And this one's not real easy to see with sine. So sine and cosine would be a bad choice. So you're going to choose something other than sine. All right, so we're going to put in our function. First of all, we're going to say what parent function are we dealing with. So I'm going to say f of x, which means it's a function. And I'm going to go with sine of x. So there's our parent function. And the next line, I'm going to write out my transformation to that parent. And we're going to include all our former things that we know about. So it's going to be a times f of x minus h. That's the one we're going to investigate today. What does that do? Plus k. I'm going to add a slider for all of them. Let's set them to our default values. A, because I'm multiplying by a, I'm taking the function and multiplying by a, our default value is 1 because multiplying by 1 doesn't change anything. I'm subtracting h, so if I subtract 0, nothing changes. So my default value for h is 0. And then for k, I'm adding k, so my default value for k is also 0. So now you can see that that translated function matches our parent function. Quick review, if we slide k, it has a vertical effect because it's outside of the function. It's not in the parentheses inside the f. Okay? Has a vertical effect. A is also outside the function. It's stretching and compressing vertically, flipping vertically. It's got a vertical effect. When I look at h, it's got a horizontal effect. It looks like it's sliding this function left or right. So I'm going to put it back to its default of 0. Almost. Okay. So let's go back and answer a couple of questions. So I did all of this stuff. Start by increasing the constant h from its default value and observing the behavior of the function. So what does h do if I increase it? If I make h bigger than 0, it seems like it's shifting the function. Now this function is a wave function. It continues on forever, so it's a little tough to see which way it shifted it. So what we can do is we can stick a point on there and see what happens. So if I define the point as f of, let's see how this works. Whoops. The point is going to be, let's see, let's go with h. So whatever h is, that's going to be the x value of my point. And then f of h, meaning I'll plug it in and get my y value. Let's label that point. Let's see if that moves with us. It starts at 0, 0, so we want to see that point as well. All right, so let's see what happens when we increase h. It's leaving it on the function. Okay, I can change that. We want to track that point 0. Okay, so now as I increase h right, you can see that point, if we track it, it moves right. All right, so as h gets bigger above 0 in a positive direction, as h goes to 5, 7, right? It shifted 7 right. So that's what happens. We increase the constant h from its default value and observe the behavior. So as h, I'll write a lowercase h, increases, above the default, the function is shifted or translated is the official term to the right. Let's decrease the constant. So now if I take h and I move it, make it less than 0, if I start making it negative, it seems to shift this function left. Oops. So that means h will be less than 0, meaning it's negative. The function is shifted that's what I wanted to say. I wanted to put the parentheses there. Shifted or translated to the left. All right, so now it says change the parent function to one of the other choices. So let's pick a different parent function. I'll make my parent function x squared. Okay, so now what this equation means is that a is 1, k is 0, so they're basically doing nothing. And then if my minus h is inside the x squared, not outside. If I make h bigger than the default value, if I make it positive, it's going right, and negative, it's going left. So the same thing seems to happen. If I change this function, my parent function, to the square root of x, right, we've got a right and a left translation or slide. X cubed for a parent function, I can slide it right and left by changing h. It's got a horizontal effect. So if we change the parent function, does h have the same effect? Yes. It still has a horizontal effect of a translation. What are the similarities and differences that the constants h and k have on the parent functions? So h shifts the function left or right. K shifts the function up or down. So one has a horizontal effect and one has a vertical effect. All right, so that's the differences. The similarity is that they're both shifting. They're both translations. So these are rigid transformations. Remember, rigid means the shape is staying the same and the size is staying the same. You're just moving the thing around. And a translation is pretty simple. You just move it left and right, left or right, and up or down. So I can apply both of those. I can move my function right and then up, something like that. I can shift right and then down. So it does have that effect on any parent function. Here's the rule. This is the tricky part because you've got your function. I'm going to just focus on the h part. If I do compare it, if I do the compare and contrast thing, if I look over here for a second, notice that in the formula h has a negative sign and k has a positive sign with it. That's why when k is positive 5, it shifts up. If k is negative 3, it shifts down. It does what you would think. Positive shifts in the upward direction, negative shifts in the downward direction. But because the h has a negative sign, it's going to do the opposite of what you would think. Now remember, it's inside the parentheses. It's in the function with x. That tells me it's going to move in the x direction, either left or right. So you would think that a positive, if you have a plus 4 in there, you would think a plus 4 would move it right, but it actually moves it left. Because this negative sign in the formula means do the opposite. And if you have a minus 3, that means it shifts it or translates it right. Even though you would think minus 3 would shift left. Here's why. Y equals f of x minus 3. Right? You're supposed to have a minus in the formula. So the minus has nothing to do with the direction. The value that's plugged in for h right here is really a 3, not a negative 3. Minus, this part is just part of the formula. So that's why 3 is considered to be positive, or I should say h is considered to be positive 3. So that would be a rightward movement, translation. If I had f of x plus 4, we know that's going to move left, but why is it really like a negative 4 for h? Because the formula needs to be written as x minus. And the way that I get x minus is I have to change that plus into a minus, a negative. So now the number that's plugged in for h here is really negative 4, which is in fact a leftward movement. We don't have to, I'm just explaining here. You don't need to kind of know how to explain that yourself. If you could follow what I'm saying, that's good. Here's what you need to know. So this is our kind of general format. So if I have y equals f of x plus 3, that's going to be a leftward, a shift left, we'll say, of 3 units. If I have, that's going to be a shift right of 2 units. These are all general functions. This guy, remember general because it's f, this is a shift up. What's the difference? The plus 2 is not inside the function anymore. It's outside the function. So whenever it's outside, you have a vertical effect. You have a shift up, not right or left. Okay, these are all horizontal. Left are both horizontal effects, left and right, because they're inside the function. These are all general functions. Let's use some specific ones. Let's look at the square root function. The first thing I would ask you is that plus 2 inside the function or outside the function? How about this plus 2? Inside the function or outside the function? This one is inside the function. This one is outside the function. Anything inside the function is considered to be grouped with the x, and x is the horizontal axis, so it's got a horizontal effect. That's just like this guy right here. It's inside the function. That's inside the function. This is outside the function, and if it's outside the function, it's considered grouped with the y, and the y axis is vertical, so this is a vertical shift. So the inside function is the horizontal. That means left or right shift. Outside the function is the vertical, which means up or down shift. Okay? So this will make more sense when we start doing the practice. And of course, I'll answer any questions you have about the video before we start. Here's some other examples of other parent functions. Here is my square function. That plus 2 is considered inside the function. I wouldn't put parentheses if I put it outside. This plus 2 is considered outside the function. You have to know if it's inside, it's with the x, it's horizontal. If it's outside, it's with the y, it's vertical. Absolute value of x. That's inside the function. This is what it would look like outside the function. We did square root, we did square. Oh, cubic. Inside the function, horizontal effect. This one is outside the function, vertical effect. Oh, one more is important, is the 1 over x parent function. If it's inside the function, it's in the denominator. Okay, it's in the denominator with the x. That's considered with the x because you could put parentheses in that denominator. If it's outside the function is 1 over x. The function in this case you could think of is as the denominator. Like here the function is anything inside the absolute values. Inside the function is anything inside the square. Inside the function is anything inside the cube. Inside the function is anything inside the square root. So in this, when our function is simply just that it's the denominator, inside the function means it's in the denominator. This is what outside the function would look like. We would just add it on the end. So this is a horizontal shift, and because it's horizontal, it's going to do the opposite of what you think. It would be left to. This is a vertical shift, and it does what you would think, up to. Okay, we'll check this out in the practice.